Hey, that was pretty fast. That hits hard, hits fast, it's pretty definite. Imagine that to be the sound of a nuke exploding. That's a slap so hard, it's gonna hit the earth. A lot of people confuse it for earthquakes. So, just a little fun fact, did you know that since World War II, 1951, there have been more than 2,000 underground tests of nuclear bombs? Did you know that since last century, we've made more than 67,000 nuclear weapons. And since 1951, we have about 10,000 of those. That's a good 6 in the United States arsenal. So today, I want to talk to you about nuclear tests, primarily underground. I want to talk to you about how that affects the seismology there, and what that does to the intelligence community, and how that affects us. Now, one thing you might be wondering, if he's going to talk about underground tests, why has he got a picture of this? This is just my favorite nuclear test. This is Sarbama, 1950. Russia's first test measured 50 kilotons. So, in 1963, moving on to the underground tests discussion, the United States, UK, and the USSR all convened and ratified a treaty called the Limited Test Ban Treaty, whose goal was to limit the arms race and to keep the spread of particulates inside the country. What it is, you test underground, stuff doesn't spread, you don't have to worry about people getting radiation poisoning 20, 30 miles away. So there's currently 80 signatory countries to this treaty, a few outliers. For instance, China, North Korea, and believe it or not, France. I don't know why they wouldn't want to sign it. I think it has something to do with the USSR. But since we're talking about treaties, let's go ahead and talk about the big treaty that affects us today. That is the Comprehensive Test Ban Treaty. Ratified in 1996, this treaty effectively prohibits every nuclear test, any nuclear explosion, be it peaceful, exploratory, or military. Since the ratification of this, there's been a few outliers that have still tested. 1998, you had Pakistan test right after India. And 2006, 2009, 2013, North Korea actually tested 3 times. The most recent test, measuring up to 20 kilotons. 20 kilotons is what we dropped on Nagasaki. So I'm glad they're late to the party. In general, when a test is conducted underground, every single bit of phenomena you're going to see concerning the test is going to be seen underground, with the exception of the crater. So you're going to see seismic waves. All this is collected seismically. The larger the test, basically, the more yield you're going to get on the Richter scale. The bigger the bomb, the more shaken of the bacon, so to speak. So for each nuclear test, you're going to notice these different phenomena. First of all, this is a Sumatran earthquake. This spawned a series of earthquakes in the year 2012. A series is where you have hundreds or maybe thousands of earthquakes in an hour. That's a lot of data to process. When you're comparing that to a nuclear test, which only happens once, there's several things you got to look for. First of all, the duration. This is maybe a 20-minute long signal. This is only a few seconds with the bulk of the data that you actually need up in here in the compressional signal. Some things you might notice in an explosive event. Positive first motion. So when I think about this is cool. In a regular earthquake like this, you'll notice the ground caving in and the seismometers, the motion's negative. The ground moves down. In a nuke, the explosive power is so great that it actually works against gravity and pushes all the Earth's mass out. Any of this data that you're looking at can be accessed in the IDC. That's a place in Vienna, the International Data Center. So concerning all this seismic data, who really uses it? Aside from various geological, international geological organizations like KIGM, the Korean International Geophysical Society, you have 2 major US customers. You have the USGS, where Randy Marsh works. Basically, this is, the USGS does a lot of seismic technology to help planning for mining test sites all over the world. And you have the United States Air Force. This is building AvTech. This is my credibility. This is where I work. Fun facts about AvTech. In 1947, September 16th, 2 days before the birth of the Air Force, General Eisenhower tasked our wing, our unit, with monitoring what's called USAIDs. That is the United States Atomic Energy Detection System. It's basically just a system, seismology, satellite observation, and a little bit of Navy play to make sure we know what's blowing up all over the world. So now that I've told you about that, I want to teach you some seismology science. Basically what happens, these signals, they're a compilation view. You have all these instruments, specific seismometers. You put them together, you get the direction for each seismometer. There's like 20 seismometers to an array. And for each array that I work with over 100. So every night I'm looking at like 400, 500 beams of seismic data. Yeah. Using this data to discriminate whether or not what I'm looking at is a seismic eruption, or excuse me, a seismic earthquake or a nuke. I also base this off of geolocation and human intelligence, if they're going to tell me if it's there or not. So what happens? You have this country, it tests, not supposed to test because of CTBT. If that country is signatory to the CTBT, it gets sanctioned. So no exports, no imports, their economy starts to fail. If it's a country that did not sign anything, like North Korea, for instance, they get scrutinized by the countries that are. So like Russia, China, they don't get to have a good economy. But yeah, is that really like enough to stop them from testing? It's not. I mean, we sanctioned them once in 2006, they didn't do anything. They're just gonna keep testing and testing until they can develop better arms. So, things that I want you to consider before we leave today. What are we doing to the Earth when we blow it up? You know, what does it say for ourselves? We're such a proactive country in determining detonation, trying to get all these sanctions placed on countries, but we have a stockpile of more than 10,000 nukes ourselves. What does that say for ourselves? Personally, I think it says that the nuclear age still has yet to end. As a planet, we need to cooperate to end this threat of life that is the nuclear age. So thank you very much for your time, ladies and gentlemen. That has been a presentation on Seismology of Nukes.